Okay, here in this video, we're going to talk about the basic graphs of sine and cosine. Now, our ultimate goal is to be able to graph our complete forms that are going to look like these two guys here, where we're going to have some phase shifts, vertical shifts, a whole bunch of really just translations. If you remember from college algebra, all those horizontal and vertical shifts and translations, contractions, all of that stuff, we're just doing that to trig functions. So these are our ultimate goal, but we're not going to get to these in this video. We're going to start with basic graphs, what just the graphs of sine and cosine look like, and then we're going to play around with the period a little bit. So let me start with an animation to motivate what's going on here. So I've got a unit circle here. My radius is 1. So if I have some angle theta here, so right now I have a 45-degree angle, then the sine of that angle will be the y value, so to speak, this vertical component, this vertical leg of this triangle, over the radius, but the radius is 1, so the sine of this angle will just be this pink length here. And if I move this point around, I guess I can't. If I allow that point to move around, that pink length is changing. So watch that pink length change. Now it's negative, it's getting bigger, it's getting smaller, it's back to 0. Now we're going backwards just for fun. So if we were to map out and keep track of how tall this pink purplish length is versus our angle. If we were to graph out our angle here in radians is our horizontal axis, and then our vertical axis will be literally that length right there, we would get this graph. So starting at 0, look, we're getting bigger. That's our maximum. Now we're going back down to 0. Now we're negative. Look at all those negative values, and so forth. That would be the graph of the sine of that angle. Now this would keep going. If we let this thing rotate around and keep going, we would keep getting this shape over and over again. So that's our basic graph of sine of x. So we can draw that here. And this one you're really just going to have to memorize. This is just y equals regular old sine of x. It's going to look like this. It starts at 0. That will be 2 pi. That's one complete circle. This will be pi, pi over 2, 3 pi over 2. My maximum height was at 1, and my minimum was down at -1. Now, if we keep letting this animation rotate around and get angles bigger than 360, all we're going to keep doing is just repeating this pattern. So this thing goes on forever. It keeps repeating this same pattern. We call this a periodic function. And it repeats that every 2 pi. So this right here we call one period, one complete cycle from here to here. So let me draw that in a different color here. Say yellow. This would be one complete cycle. And then it just repeats that every 2 pi. So this next one, let me draw him in a different color. Say purple here. That takes another 2 pi. So if this was at 2 pi, this next one would end at 4 pi. And the next one would end at 6 pi and 8 pi and so forth. And we could even go backwards. Here, I'll do a different color even. Let's go red. This complete cycle going backwards, that would end at -2 pi. And so forth. This goes on and on forever. So we call that distance from start to finish the period. So the period of regular old basic y equals sine of x is 2 pi. We're always going to be doing these in radians. If we were to do it in degrees, the period would be 360 degrees, one complete circle. But we'll always do it in radians. Okay, some important points on here. So these top points here, these high points, we call these crests. These low points, we call troughs. Think of an ocean wave bouncing out on the ocean. The high points are the crests. The low points, the dips, are called the troughs. This right here is our midline. Will be, in this case, the x-axis comes right through the middle. This distance from the midline to the top. Not the whole distance top to bottom. This distance right here from the middle to the top we call the amplitude. Right there. So if you go to the ocean, I don't know, maybe you're a surfer and you hear there are 10-foot waves today. When they say 10-foot waves, they don't mean from the bottom to the top. This is not 10 feet. What they mean is from flat ocean, 10 feet above what would be calm seas, flat ocean. So when they say 10-foot waves, they're giving the amplitude, the height from what would just be flat. Okay, so this is the basic graph of regular old sine of x. What we're going to do today in this video is play with that period. If I were to throw a number right there in front of the x, a b value in front of the x, that will change the period. It will make this thing oscillate faster or slower. Later on, we're going to shift it around. We call that a phase shift if we scoot it left and right. Or we'll add on a vertical shift if we move it up and down. And anytime we can play with the amplitude by changing this number in front, and that'll just change how high and low it oscillates. Okay, so that's our basic graph for sine. What about cosine? Well, if I have some angle here, let me get my angle back to the beginning. Let me start this guy over. Not letting me click. There we go. There's our cosine. So cosine, instead of measuring the vertical component, we're measuring the horizontal component. If I pick some angle right there, say 55 degrees, and I draw in this right triangle right here, then the cosine of that angle will be the adjacent over hypotenuse. But remember, we're in a unit circle here, so our hypotenuse is 1. So this length here will be the cosine of that angle. And if I allow this thing to rotate around and I plot out all these horizontal lengths here versus the angle, then I'll get a graph that looks like this. Notice that it starts at 1. When my angle was 0, this thing is as long as it's ever going to be. This little green line here. And it's getting smaller. You can watch the little green line is getting smaller. Now they're negative values. See, those are negative values. They're behind the origin. Getting smaller, going positive again, and so forth. So that's our basic graph for cosine. It looks just like sine, only it starts at a crest. So cosine is going to go like this, and it's going to just keep oscillating over and over again. Remember, our domain of sine and cosine for both was all real numbers. I can plug in any angle I want, and my range was -1 to 1. This guy goes all the way up to 1, down to -1. My period, my distance between, say, one crest and the next. Here's one complete cycle. Here's one period from here to here. Is 2 pi. So that's 2 pi. Halfway there. What's halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2. This spot is 3 pi over 2. Notice that in one period, we've got 4 important points. I've got this crest, this x-intercept, this trough right here, and then this next x-intercept. In each period, there are always going to be 4 important points. Crest, intercept, trough, intercept. Then I move on to the next one. So then I would have crest, intercept, trough, intercept. I call that distance here between one important point and the next the x scale. Think of it like on your calculator when you pick your scale, or if you're on graphing paper and you draw, you're drawing a graph and you're counting by something. Sometimes you go 5, 10, 15. Sometimes you go by 5s. Sometimes you go by 2s. Maybe you'll go 2, 4, 6. What we're going to be counting by, how we're going to be labeling our x-axis, is the scale. And for regular old sine and cosine, our scale, we're counting by pi over 2s. Then here we can look. There's 1 pi over 2. 2 pi over 2. Those 2's would cancel. That's just pi. 3 pi over 2. That guy there is 4 pi over 2. People that struggle with graphing trig functions, the place they usually struggle is with fractions. 4 over 2 is just 2. The pi just comes along for the ride. And let's keep going. Let's keep labeling. I'm counting by pi over 2's. Forget about the pi. I'm counting by halves. There's 1 half, 2 halves, 3 halves, 4 halves, 5 halves. 6 pi over 2. That spot right there would be 6 over 2. Well, that's just 3 pi. That was 6, and next would be 7 over 2. 8 over 2. 8 over 2 is better known as 4 pi. I could go backwards. Negative pi over 2. I won't even bother reducing these fractions. Negative 2 pi over 2. Negative 3 pi over 2. Negative 4 pi over 2. So all I'm labeling are all the crests, intercepts, troughs, and intercepts. Okay, those are my basic graphs for sine and cosine. What we're going to be doing is changing the period. So my new period will be the old period over b, a number I put in there. You don't have to learn all this now. We're going to build all this up. We're going to shift these things left and right. We call that a phase shift. We're going to move them up and down. We call that a vertical shift. That's this number outside k. Okay, that's a good place to stop on this one.